Okay, so let's start off. And the general formula for most of these types of problems is that work is rate times time. So the amount of work done is just going to be the rate of the work times the amount of time you actually spend doing that work. So that, of course, seems pretty intuitively obvious. So let's try this with a simple example. If Bill can eat 30 cookies in 6 minutes, how many minutes will it take him to eat 75 cookies? So there's actually two ways to do this, but for now I'm going to use the method that uses this formula. Okay, so how much work is being done? He's eating 30 cookies. So 30 is the work. So he's eating 30 of them. And there's some rate. We don't know what rate he eats them at, some rate R, times the amount of time he spends. And he spends 6 minutes, so 6. And then from here we can find that R is 30 divided by 6, or 5. Okay, now what's the next thing we can do? Well, we know that 75 cookies, how long will it take him to eat that? Well, yeah, so here basically what I mean is that there's the 5 means that he can eat 5 cookies every single minute, because that's his rate. Cookies per minute. Cookies per minute. That's what R is. So this is 5 cookies per minute. So now we have the 75, the amount of cookies is just equal to the number of cookies per minute, which is 5. So 5, because he eats 5 cookies per minute, times the amount of time he takes. We don't know what that is. That's what we're trying to find, how many minutes he takes. But then from here we can find that, okay, T is just 75 divided by 5, which is 15, which is our actual answer. That's not the answer. It's just the cookies. Yeah, so this is the general idea. To solve it, you plug it into this formula twice. So first you find R, then you plug it in to see what the value of T is for the second scenario with 75 cookies. And the other way that probably most of you would have done is that it will take, we take for 36 minutes to get 30 cookies. And that means that for 75 cookies, we need 75 over 30 times 6 cookies, 6 minutes. Because now we have to eat 75 over 30, the number of cookies. So that means we will take 75 over 30 times longer. So we will take 75 over 30 times 6. So this is equal to 75 over 30 times 6. Yeah. And basically what I'm doing here is I'm using ratios, which I'm trying to do here. And we can cancel. And we get that this is just, and from here, this should be 5. It's going to be 5. So this is just 75 divided by 5, which is 15. Any questions on this problem? So let's move on to the next example problem. John can paint a room in 6 hours. Emily in 3 hours when working alone. If they work together to paint the room, how much time will they need to finish painting the room? So this is a little bit more of a tricky problem. So if John can paint the whole room in 6 hours, he can paint in 1 hour. So if he can paint the whole room, so I'll just say one room. So one room in 6 hours. He can, in just 1 hour, so let's say he takes only 1 hour, he can only paint 1/6 the amount of rooms. He can only paint 1/6 of a room. Right? Because this is we're just multiplying by 1/6. Times 1/6 and times 1/6. So therefore in 1 hour you can paint 1/6 of a room. Okay, so now also the same thing for Emily. Emily can paint one room in 3 hours. So we can multiply by 1/3 and both sides. We get in 1 hour, Emily can paint 1/3 of a room. Okay, so now what? So we're working together. So John can paint 1/6 of a room in an hour, Emily can paint 1/3 of a room in an hour. So together, they can paint 1/6 plus 1/3 of a room. So together, they can paint not just 1/6. So Josh can paint 1/6 in an hour. Emily can paint 1/6 in an hour. So together, they can paint 1/6 plus 1/3 of a room, which is just 1/6 plus 2/6, which is 3/6, or 1/2. So working together, they can paint one room in 1/2 of an hour. But then how long will they need to, sorry, it would be 1 hour, they can paint half the room. So in 1 hour, they can paint 1/2 of the room. And that means that in 2 hours, they can paint the whole room. One room, the whole thing. So that means the answer is 2. And a very common mistake on this problem is that they say, okay, Josh in 6 hours, Emily in 3, and then you just add them up. So you just do 6 plus 3 is 9, and you get 9. That's a very common mistake that many people would do. And the reason that this doesn't work is because John can paint a room in 6 hours, Emily can paint it in 3 hours. You can think about it that, so 6 hours for Josh, 3 hours for Emily, but working together, since they're having 2 people working at the same time, it should actually take less time. It should not take more time, because if the answer is 9, that means when they work together, it takes even longer to do it. But that doesn't make sense. So just keep in mind that this method won't work for these types of problems. So are there any questions? Okay, let's move on to problems from MOEMS. Richard parked his car in the parking lot from 9:10 a.m. to 10:50 a.m. and it cost $1 for every 10 minutes. How much did he have to pay in total? So here, this is one of the easier problems. So what we do is you have 9:10, and then how long will it take to get to 10:50? So how much time passes between these two intervals? How much time does it take? Well, after 1 hour, you get to 10:10. And after 40 more minutes, you get to 10:50. So overall, it takes 1 hour and 40 minutes. It takes 1 hour and 40 minutes he's parked his car for 1 hour and 40 minutes. And we know 1 hour is 60 minutes. This is equal to 100 minutes. So it takes 100, he parked his car for 100 minutes. Okay, so now if he has 100 minutes, and he gains $1 for every 10 minutes, so he's 100 minutes divided by 10 minutes, which is 10. So that means he's going to pay $10, because for every 10 minutes, he pays $1, and there's 10 of these 10-minute groups. So when we divide by 10, we have 10 of these 10-minute sections. So essentially, there's 10 times 10 of these 10-minute things. So that way it's going to be $10. Any questions on this problem? Okay, let's move on to the next problem. Okay, so now we're going to use another very important technique. So this is another important technique that comes up often. So let me make sure you understand how this technique works. So basically there are 10 workers that can dig 20 holes. So let me just write out actually. So we have 10 workers. They can dig 20 holes in 40 days. Okay, so now we're asked to find how many days 20 workers would take to dig 10 holes. Okay, so let's say instead of 20, now we have 20 workers. And we want them to dig 10 holes. Or let's actually keep it. So let's say, how long will it take 20 workers to dig 20 holes? How long will it take that? So now we're taking this problem piece by piece. So now let's just say instead of 10 workers, we have 20 workers. Now how long will it take? So the key thing here is that we have twice the number of people. So we have twice the number of workers. So we have 2 times the number of people that are working. Because now if you have 2 times the number of people that are working, it's only going to take half as long, right? Because now we have 2 times the number of people who are going to actually work. So the amount of time is just going to be halved, because now it won't take as long since we have 2 times the number of people working. So therefore the time is just going to be 1/2 times 40, which is 20 days. Okay, now let's look at the second part. How long will it take 20 workers to dig 10 holes? This is what we're asked to find. So 10 holes. Well, now in this case, we have half the amount of work. So now we only have half the number of, they only have half the number of things to actually do. And since they only have half the number of things to do, it's only going to take half as long. So that's why we're just, all we really have to do is just multiply it by 1/2. So you know how we have 20 days here? It's just going to take that times 1/2. So that the answer is just going to be 10. Any questions? So again, highlighting the key steps. We have twice the number of workers, but then we have twice the number of workers and half the amount of time and half the amount of work to do. So since we have twice the number of workers, it will be half as fast. But since we have only half the amount of work to do, and basically what this essentially the main idea is that now we have twice the number of people who are working. So now we have twice the number of people who are actually working, but we only have half the number of things to do. So we only have half the things, twice the number of people working. So overall, it's going to take only 1/4 the amount of time. And but basically what we're doing is that this is what we're given. We're given this statement, right? 10 workers can dig 20 holes in 40 days. I just marked it here. And then we're saying is, okay, now instead of 40 days, what about 20? How many would it take for 20 workers to dig 10 holes? So that means now, how much would it take 20 workers to dig 20 holes in 20? And we found that it's 20 days. And we're changing each part. So we're changing the part, okay, how many workers? And then after that, okay, now we have 20 workers, 20 holes. Instead of just 10 workers, 20 holes. But now we need it in 10 holes, not just 20 holes. And then we change the holes part. So we make it, instead of just 20 holes, now we have 10 holes. And that's why it's just going to be half the amount of time. So we change, in each step, we change one thing. And then we just find out what it is, and then we multiply the ratios accordingly. So any questions on this general idea? Because we're going to be using this in many other problems, so make sure you understand why and how this works.
I don't have any questions.
Let's move on now, then. Okay, so remember the second problem that we did today? It says that tap A fills in 6 minutes, tap B fills in 8 minutes. It was a similar style problem. And tap B will fill the same hot tub with hot water in 8 minutes, but then we're combining them. So now it's flowing out of tap A and tap B. So how long will it take? So we can take that same one third, 1/4, that kind of approach. We take fractions. But except in this case, it's not 1/3 and 1/4. So the whole tub, so one tub, like this is tap A. So we're doing tap A here. So one tub can be filled in 6 minutes. So that means that in just 1 minute, you can only fill 1/6 the tub. Right? Because we're multiplying by 1/6 to both sides. Okay, now what about for tub B? Again, one tub in 8 minutes. So that means in just 1 minute, we can only fill 1/8 the tub. Right? The same kind of style of approach. We find the fraction that each of them do in one time unit. So in 1 minute, A does this much. In 1 minute, B does this much. So then overall, in 1 minute, combined, they fill 1/6 plus 1/8 the tub, which is 4/24 plus 3/24, which is 7/24. So combined in 1 minute, so combined A and B, they can fill in 1 minute, so in 1 minute, they can fill 7/24. And now we're asked to find how long will it take to fill the whole tub. So for them, 7/24 of a tub. Let me write that, 7/24 tub. So that means to fill the whole tub, we must take 24/7 the amount of time. So again, we just multiply the same thing to both sides. We multiply the amount of tubs, multiply to minutes. And this gives that one tub, because right, the 24s will cancel, the 7s will cancel. One tub can be filled in 24/7 minutes. That's what you're asked to find. How long will it take to fill the tub with both taps? Any questions?
Nope.
Okay, let's move on to number 4. Ben takes 6 days to renovate the room, and James takes 15 days to renovate the same room. James started by renovating the room first and left the rest of the renovation to be completed by Ben. It eventually took 9 days to complete renovating the room. At this rate, how many days will it take Ben to complete the job? So this is one of the more tricky problems that we have for today. So I'm going to spend more time in trying to explain it clearly. So Ben takes six days to renovate one room. So again, that same idea. Ben, hopefully by now it's clear that if he takes one room in 6 days, for 1 day, he can only do 1/6 the room. Hopefully by now this idea is clear. But then James, well, for James, they take one room 15 days. And that means that it can do 1/15 of a room in 1 day. So again, that's the same thing that we've been doing for the last problem and the one that we did in the beginning. Okay, so now here's where the tricky part comes in. So now we somehow set up an equation. Here's how you do that. So it says that James starts renovating the first and leaves the rest to completed by Ben. So do we know how much of the room James is renovating? Do we know how much James is actually renovating? No, we don't know what it is yet. So let's just say that James renovates X, a fraction of the room. So let's just say X can be like 1/3, maybe to 1/2, maybe 2/5, something, some fraction. We don't know what it is. So let's just say that James is doing X, a fraction X of the whole room. That means that Ben will do 1 minus X of the room, because overall, together they have to complete one room. Right? Oh, this is clear to everybody? How we got until here? Yes, okay, then let's continue. So yeah, again, X is the amount that James is doing, 1 minus X is the amount that Ben does. So if James does X of the room, we know that James can do in 1 day he can do 1/15 of a room. So if he can do X, a fraction X of the room, and he can do 1/15 of a room every day, how long will it take James to do X rooms, a fraction X of the room? So how long will it take to do a fraction of the room? Given that he can do 1/50, how many days will it take him to do this fraction X of a room if he can do 1/15 of a room in one day? Well, the idea here is that if he can do 1/15 of a room in a day, he can do X rooms, however many that is. So we're just multiplying by, he can do it in since he can do X rooms, it's just going to be X over 1/15. And the reason for this is that he can do X rooms. He can do X rooms every single day. So on this day, he can do X rooms, so a fraction X of the room. And then each day he can do 1/15 of a room. So then overall, in order to fraction X of the room, he needs to be able to do X over 1/15. So we multiply by X over 1/15 here. That means you have to also multiply by X over 1/15 here. Right? That's how long it will take him to do X rooms. So he'll take X over 1/15 days, however many that is. We don't know. So I wrote it out over here. And now what about Ben? Does anybody know what it is for Ben? It's very similar to what we did for James. So now except instead of X, he has to do 1 minus X. 1 minus X rooms. So how many days will it take that? Does anybody know what we can do from here? So what we do is we multiply by 1 minus X over 1/6. Right? Because that cancels out the 1/6 term, and now we get 1 over it. That's what we do to multiply it. And then we do the same thing on the other side. 1 minus X over 1/6. That's the amount of days. So we get that there's not a space right here, so I'll just write 1 minus X over 1/6 days. So 1 minus X over 1/6 days for Ben to complete 1 minus X rooms. So this is just 1 minus X over 1/6. Let me write it out to make it clear. This is just the number of days that Ben will take. Days for Ben. So this is just the number of, this should be James. This is the number for James. This should be the number for James. So this is the amount of days it will take for James to complete X of the room, right? Completes his work. And similarly, this is days for Ben to complete 1 minus X of the room. So 1 minus X of the room. So is this stage clear to everybody how we got that? Because this is James for Ben. This is the one for Ben. I mean James. This is the one for Ben. And then that's just the number of days. We just multiplied it here. So are there any questions on this part? Yeah, so this is a very confusing, so don't feel bad if you don't have to ask questions. Because the idea here is from here, in order to do 1 minus X rooms, he gets this much fraction in order to get that many days. So we multiply that to both sides. Because 1 minus X rooms can be done. You just multiply it by this fraction here. And the same thing on this side. To get 1 day, we multiply by this fraction to get the amount of days it will take to complete 1 minus X rooms. And then the same thing here. I'll explain more of it at the end of the problem. And what is this? Does anybody know what this is equal to? This is the days for Ben to complete it. This is days for Ben to complete his part of the room, which is 1 minus X. So what do they have total? Well, total, this is just going to be total, days total days total to complete. And do we know what this is? Well, we're given the problem that they eventually took 9 days. So both of them combined, they took 9 days. So this is just 9. We're given the problem that they combined took 9 days. And now, let me write it down a little bit here. So now we have to solve this equation. So x over 1 over 15 is just going to be 15x. And 1 minus x over 1 by 6 is just going to be 6 times 1 minus x, which is going to be 9. And this means that 15x plus 6 minus 6x is 9, which means that 9x plus 6 is 9. Or 9x is equal to 9 minus 6 or 3, which means that x is 3 over 9 or 1/3. So again, I'm just solving this one variable equation now. So now we have that x is 1/3. So what does that mean? That means x, the amount of days James will take is 1/3. The amount of days Ben will take is 2/3. So 1 minus x is just 1 minus 1/3 or 2/3. So that means that we know James does 1/3 the room, and Ben does 2/3 the room at a rate of 1/6 of room per day. And again, James does 1/3 of the room at a rate of 1/15 of a room per day. So now what is the answer? How many days will Ben take? Well, he completes 2/3 of the room, and he can do, in 1 day, he can only do 1/6 of a room. So we just do 2/3 divided by 1/6, which is 4/6, divided by 1/6, which is 4. So the answer is 4. And again, just like we do for many, many other problems, let's see if our answer is correct. So let's put it back into the problem and see if it's actually right. Okay. So now, is this clear? Is this method clear to everybody? Because now I think I need to erase to get some space. So yeah, I'll just erase it there. Okay, so Ben takes 6 days, and James takes 15 days. And so we know that so now let's just plug it back into our equation to see if our equation actually does hold. So James will take 1/3 of a day. Okay, so James will take 1/3 of a day, right? And we already know it's going to take he's gonna finish 1/3 of the room, and he's going to take 1 by 15th of the room in each of the days. So it's going to be 1/3 divided by 1 over 15, which is just 5. Now James takes 5 days, Ben takes 4 days. And so now we know that. So now we know that this is the number of days James takes. Because now we can just quickly put it back in the problem. If James takes 5 days, and each of those days he completes 1/3, and sorry, each of those days, so James will take 5 days, Ben will take 4 days, so it's just going to be 4 times 1/6, and it's going to be 5 times 1 over 15, since James does 1 over 15th of it in a day, plus 4 times the amount Ben can do, which is 1/6. Because remember from this original thing over here, Ben can do 1/6, James can do 1/15, and you see this is 1/3 plus 2/3, which is 1. So overall, they complete the whole room. Okay, so now are there any questions?
No.
This is one of the harder problems that we're going to be doing today. Okay, so now we're going to explore a very problem that's really easy to get wrong. Okay, so try solving this on your own. So if it takes 5 minutes for 5 moles to dig 5 holes, how many minutes will it take 6 moles to dig 6 holes? So does anybody know what the answer is? To this problem?
6 minutes.
Okay. Yeah, like I said earlier, this is a problem that's okay. So now I think I'll go into the solution. Some people have said 5, which is the correct answer, and many people are saying 6. And many people, this is actually somewhat of a trick problem, so don't feel bad if you got 6. So if it takes 5 minutes, you think, okay, 555, it has to be 666. And here's where that logic actually is flawed. So the reason you might think 6 is because if it's all 5s, it has to be all 6s. But that logic is not right. And now let me explain why. So 5 minutes for 5 moles, 5 holes. Okay, so now let's just say we have 6 moles. So now we have 6 moles and 5 holes. So how many minutes will it take if we have 6 moles and 5 holes? It's going to take, well, we have 6/5 the number of people, 6/5 the number of things that are working. So it's only going to take 5/6 the amount of time, since we have more actual workers. So we have 6/5 the number of workers. So it's only going to take 5/6 the number of workers times 5 minutes. And this means that it's going to be 25/6 minutes. Okay. Now let's change the second part. Now, how many minutes will it take for 6 moles to dig 6 holes, right? That's our problem, 6 holes. And in these types of problems, we want to change 2 things, right? So now let's change one thing first. We change the number of moles and then change the number of holes. So you can change both of those things. So we change one piece at a time. 25/6. So now 6 moles, 6 holes. But now we have 6/5 amount of actual work to do. So now it will take them 6/5 longer because now we have 6/5 more things to do. So now what we do is we multiply 25 by 6 times 6/5, which is 25 divided by 5 or 5. So is it clear to everyone why the answer is not just going to be 6 and why the answer is actually 5? And again, this is a somewhat of a trick problem. So don't remember, whenever these problems, don't just assume it's just going to be 6. Remember, with this 2-step approach, first we find, okay, what if we change one part? Then now we change another factor, and we get our answer. So are there any questions, or does everyone understand this problem? So make sure you realize why the answer is not just going to be 6. Okay, so hopefully that made sense. We just take it 2 steps at a time. In general, the thing that you should remember from this problem is that don't try to assume stuff about the problem. Just make sure you use one of the methods that we learned or some other method and just do it systematically without just making something that's just going to be 666. And don't worry, this is again a really common mistake. Most of the people who solve this problem actually would put 6. So this is a very interesting problem because most of the people who did this actually got it wrong. Let's move on to the next problem. So this is a pretty easy problem. Anne takes 8 minutes to run around the school track. Sophie can run around this track 8 times in 1 hour. Who is faster? Okay, so Anne will take 8 minutes for one track, for one lap. And Sophie will take, well, he can do 60 minutes for 8 times. So it's going to be 60 over 8 minutes for one time, which is equal to 7.5 minutes. You can just divide that out. Okay, so now who's faster? Well, you can think about the distance. So let's just say the distance that he travels in the path is some distance d. So that means Anne's rate, so this formula we're using here is that we have the distance is equal to the speed times the time. So distance divided by 8, which is Anne's rate, is equal to Anne's rate. So Anne's rate. And similarly for Sophie, it's just going to be distance divided by 7.5, which is Sophie's rate. So which one is larger? Well, clearly this one is larger because now we're dividing by something smaller. Here we're dividing by a big number, 8. But now here we're dividing by a smaller number, 7.5. So Sophie's rate is going to be faster. So the answer is just Sophie. Intuitively, without doing all this D stuff, you can just think, okay, if Anne is going to take longer to complete the track, now she's going to take more time. That means she's going to be slower. And Sophie, she can do it faster. She can do it faster, so she's going to take less time. That's the way to intuitively do it without doing this D stuff. Any questions on this problem?
No.
Let's move on to the next problem. So this is again one of those problems where you change one thing at a time. So 3 men can take 2 days to paint 5 fences. How many days will it take for 2 men to paint 1 fence? So try to use that 2-step approach, change one thing at a time, and try to get the answer. So again, try to use that same approach that we discussed in many of the previous problems. Change one thing, multiply by something, then multiply by something else, to both sides, to do to both sides too. Then get some answer here. So now I'm going to give a hint. So for the first part, multiply by 2/3. I should see this. So multiply it by 2/3. And after that, multiply this part by 1/5. And then you can adjust things accordingly. Adjust the number of days based on that. So I'll give you another minute or so to try this. Okay, let me go over the solution now. Looks like some of you got it, so that's good job to you. So here's what we did here. it's going to be 2/3 the number of men, right? So if there's 2/3 the number of men, how much longer is it going to take? So if you have 2/3 the number of people actually working, it's going to take 3/2 longer. So just let me erase the question marks. So originally we have 2/3 the number of people working, so the time is going to increase by 3/2. So 3/2 times 2, which is 3. Because now we have 2 men, 3 days, 5 fences. But now we see, as you see here, we only have 1/5 the actual work to do. So if you have only 1/5 the work to do, it's gonna be 5 times faster since we only have 1/5 the actual work to do. So 5 times faster. And if it's 5 times faster, the time is going to be 5 times less. So the time is just going to be 3/5. 3 divided by 5. And that's the answer. How many days will it take for 2 men to paint 1 fence? 3/5. Any questions? So remember this same thing. Take it one step at a time. First, you change the number of days. Then you change the number of fences in this problem. Yeah, and again, those are the same thing that you should be doing for most of these problems. Change one thing at a time. Change the first thing, which is then, and then the fences. Just keep doing that for any of these types of problems. Let's move on now. 2 pipes are used to fill a pool with water. Water flowing through the first pipe can fill the pool in 3 hours. The second pipe in 4 hours. How long, the water flowing from both pipes, how long will it take to fill the pool together? So again, here's the same type of idea. So we did a very similar problem, so try to solve this on your own again. So in this case, we have from the first pipe, so say pipe number 1, in one pipe for 3 hours, so sorry, one pool for 3 hours. So then in 1 hour, how much? Same thing on the other side. For 2, let's say that for the second pipe, we have one pool in 4 hours. So in 1 hour, how much? And then try to use that same approach. Try to use that same approach, and then at the end, you get the rates for each of them in 1 hour, and then you can just add them together. And then you can do something for the combined 1 and 2. Okay, let's go into the solution now. Again, some of you got it, so that's good. So in 1 hour, in this case, you have 3 hours for one pool. In this case, we have 1 hour, so times 1/3. Can we do 1/3 pool? Right? Same thing here, times 1/4. Since we only have 1/4 the number of hours, And that means it's going to be the number of pools is just going to be 1/4. So 1/4 times 1/4. So 1/4 pools. And then combined, how much? So combined, they can do 1/3 pool in an hour. The first pipe can do 1/3 pool in an hour. The second pipe can do 1/4 pools in an hour. So combined, they can do 1/3 plus 1/4 pools in an hour, which is 4/12 plus 3/12, which is 7/12. So combined, they can do, in 1 hour, they can do 7/12 of the pool. And then we multiply by 12/7 to both sides. And then what we do is, that means at the end, you have that 12/7 is the number of hours. So the answer is 12/7. So those are the key steps of the problem. Are there any questions? Let's do number 9. Alice and Betty so we're going to spend less time on this problem, because number 10 is the harder problem. Alice and Betty run a 50-meter race. Alice wins by 10 meters. Then they run a 60-meter race. But then each girl runs at the same speed in the first race. But how many meters will they win? So here's the idea here. We have 50 meters. So let's say 50. And Alice wins. So when Alice wins, when she reaches the end, Betty is 10 meters behind. So Betty only gets to complete 40. Right? Betty can only complete 40 because she's 10 meters behind from Alice at the end. So now we're asked to find for the 60 case. Does anyone know what we can do from here? So again, the idea here is that the ratios of their speeds, so let's just say Alice's speed is going to be A. Or actually, there's no point in doing that. Never mind. Let's just say, look at the ratio of their speeds. The same ratio of the speeds will apply. So Alice will reach here. How many meters ahead will she be from Betty? So as I said earlier, the hint here is that the ratios of their speed is the same. So when Alice goes 50, Betty goes 40, what is the ratio of their speeds? Does anyone know what the ratio of Alice's speed to Betty's speed is? Does anyone know what the ratio of the speeds from Alice is? Because Alice can go 50 meters and Betty can go 40 meters. So what is the ratio then? It's just 5/4. Right? Because Betty goes 40 meters, at the same time Alice goes 50 meters. But that same ratio of speeds is going to apply for the second problem. When Alice goes 60 meters, Betty will only go 4/5 of 60 meters, which is 48. So Betty's only going to be able to go 48 meters the time that Alice goes 60 meters. So then how many ahead of Betty is Alice? Betty is going to be 12 ahead, 60 minus 48. That's our answer here. Any questions? Now we're going to move on to the last problem. It's a little bit tricky. So Eileen takes 2 days and Eve takes 3 days to sew 48 dresses together. If Eileen takes 4 days and Eve takes 2 days to sew 64 dresses all together, how many days will it take each of them to sew 48 dresses? Okay, so what variables can we assign in this problem? What are our variables? So our variables, we're going to say that A is, well, the number of dresses Eileen can do in one day. And let's say B is, sorry, not B, let's say E. E is the dresses that Eve dresses per day. Okay, so now let's use these variables. So Eileen takes 2 days and Eve takes 3 days to sew 48 dresses. That means that 2 days, so 2 times the amount Eileen can do in a day. So 2 days times the amount Eileen can do in a day, plus 3 times the amount Eve can do in a day is 48. If Eileen takes 4 days and Eve takes 2 days to do 64 dresses, so Eileen takes 4 days, so 4 times the amount of dresses Eileen can do in a day, and Eve takes 2 days, so plus 2 times the amount Eve can do in a day, and 64. We're asked to find how many days each of them take to sew 48 dresses. So now we have a 2-variable equation, and now we can just solve it. So we can solve it using 2 ways. I sent you a video a couple weeks ago on a faster way to solve 2-variable equations. So if you watch that video, you can solve the equations using that method. Or if you haven't watched the video, it's okay. We can just use the regular method. So what we do is we do times 2 here, times 3 here. Now this is 4a plus 6e is 96. Now we have 12a plus 6e is 192. And then we just do this equation minus this equation. We get 12a minus 4, but let me just write it out more clearly. 12a plus 6e now what we do is we subtract. We get AA, 60 cancel is 96. That means that A is 96 divided by 8, which is 12. And if A is 12, well then 2A is 24. And that means we have that 2A, 24 plus 3E is 48. So 3E is just 48 minus 24, which is 24. That means that E is 24 divided by 3, or 8. So A is 12, E is 8. And that's our answer. That's not our answer, sorry. That's the rate. So now we have this is 12. This is 12. This is 8. So now we're asked to find how many days it will take to sew 48 dresses for each of them. Okay, so for A, what we have is that, let me actually move this down. Okay, so for A, we have that it's just going to be 48. So 48 dresses, she can do 12 per day. So it's going to be, the amount of days is just going to be 48 divided by 12 or 4. So the amount of days A will take, days for A. And those are going to be 48 divided by 8 equals 6. This is the days for B, since he can do 8 dresses per day. So it's going to take, since to do 48 dresses, it's going to be 48 divided by 8, or 6. So this is the days for E. Okay, so that means that our answer is just for A, it's going to be 4. For E, it's going to be 6. And we can always plug it back into our problem. So let's do that. So so we can always just plug back these numbers. So we see that, okay, if Eileen can do it in 2 days, takes 2 days, Eve takes 3 days. So if Eileen takes 2 days, that means it will be 24 dresses. Eileen makes 24 dresses here. Eve makes 3 times 8, or 24 dresses. And we see that 24 plus 24 is 48. So we see that yes, the first equation is good. The first statement is correct. Now, if Eileen takes 4 days, so 4 times 12 is 48. Neve takes 2 days, 2 times 8 is 16. You add them up, you get 64, which is correct, right? 64 dresses. And therefore, our answer is correct. So we know it's right. And after that, the calculations to get the number for 48 dresses was pretty easy and straightforward from there. So any questions on this problem or any other problem? So that would be it for today. If you have any questions, feel free to ask them right now. Otherwise, thank you for coming to this class and see you tomorrow for our last class.